Hello, this is going to be lesson 12.3. We are going to be covering pages 387 to 391. We're going to be talking about using the Pythagorean theorem to find the distance on the coordinate plane. The standard we're going to be working in is standard G8. I can apply the Pythagorean theorem to find the distance between 2 points in a coordinate system. So let's get started. We're going to go under the document camera. So this is page 377, and this is the first example you have in your book, example 1, approximating the length of the hypotenuse. So you have here a drawing, and we have a coordinate plane here, so we can count squares. So we're going to figure out the length of this leg and the length of that leg, and we're going to try to find the hypotenuse length. And it says here, the figure shows a right triangle. Approximate the length of the hypotenuse to the nearest tenth using a calculator. So let's count how many units this side is. 1, 2, 3, 4, 5. And let's count how many units this one is. 1, 2. Actually, I think in your book it's 4. I drew it 1 extra. 1, 2, 3, 4, 5. So your answer is going to be different than the books. So to do the Pythagorean theorem, remember what it is. It's a squared plus b squared equals c squared. And we know that one of these two legs is a. We'll call this a. This is b. And the hypotenuse, that's the side across from the right angle. There's your right angle. Looks like an L, backwards L, upside down L, some kind of an L. So C is your hypotenuse. So now we just plug in the numbers. So we have our A is 2, so 2 squared, plus our B is 5, 5 squared is equal to our C squared, which is what we're trying to find out. So 2 squared is 2 times 2, that's 4, plus 5 times 5, that's 25, and that's equal to c squared. Now I add 25 plus 4, so that's 29. I'm going to actually come up here now. That's 29 equals c squared. How do I find c? I take the square root of both sides. So the square root of c squared is just c, because c times c is c squared. And the square root of 29, I'm most likely going to have to use my calculator for, or you can estimate, right? So it's going to be 5.385, and we're going to do it to the nearest tenth. Now, if you needed to estimate and you didn't have a calculator, you would say, well, 5 times 5 is 25, right? We did this at the beginning of the year. And 6 times 6 is 36. So we know our answer is going to be between 5 and 6. And it's going to be closer to 5 because 25 is closer to 29 than 36 is to 29. So it's going to be a little under 5.5. So that's where we get that answer from if you don't have a calculator. So I'm going to round this to 5.4 because it told us to round to the nearest 10. So C then, and I have a different color, C then is equal to 5.4. And that's about right, right? You can see that it looks about right. I'm going to get another color here that I can maybe use here. Okay, so now let's try another one. This is the bottom one, your turn, number 1. So it says, approximate the length of the hypotenuse to the nearest tenth using a calculator. Well, let's figure out the legs. Now, if you look, this is an upside down triangle, right? This is still the right angle. It's just an upside down L. So the hypotenuse is across from the right angle. This is your hypotenuse now. And this could be your A, and this could be your B. Again, A and B doesn't matter until you get into trigonometry. So A squared plus B squared equals c squared. And we have to figure out what this distance is. Well, let's count. 1, 2, 3, 4, 5. And what's this distance? 1, 2, 3, 4. So my a squared is 5 squared. My b squared is 4 squared. And that's going to equal c squared. 5 squared is 25. 4 squared is 16, and that equals c squared. And if we add 25 plus 16, what do we get? 41 equals c squared. Now that's not a perfect square, so we can use our calculator or we can use estimation. And I used my calculator and got the square root of c squared, and the square root of 41 is 6.4 equals c. You could also tell it by saying, well, 5 times 5 is 20, or 6 times 6 is 36. This is how you estimate. 6 times 6 is equal to 36. 7 times 7 is equal to 49. 41 is right in between there. A little bit closer to 36 than it is to 49, so it's a little bit closer to 6. So that's where 6.4 came from. So the length of this side here is 6.4. Okay, now we're going to move on to deriving the distance formula. This is a formula you are going to use a ton in geometry when you do that course. So you're definitely going to want to know how to do this. We're going to derive it using the Pythagorean theorem. This Pythagorean theorem is helpful for so many things. So page 388 is what I'm working from. It's a little bit confusing on the page, so I'm going to break it down a little differently. So we're going to start with the fact that we have this right triangle with 3 coordinate points, P, Q, and R. So part A says to find the distance between P and Q, draw a segment PQ and label its length D. So that was doing this, drawing this connecting P and Q and making this segment. And I'm going to label that distance D. Okay, we also know that it's what? Compared to here, it's the hypotenuse, right? And then it says the draw horizontal segment PR, which I did already. Move it up a little bit. And vertical segment QR. I drew that line already. Label the lengths of these segments A and B. I wonder why we would be doing that. So let's call this A. Let's call this B. Starting to look familiar, isn't it? Label the lengths of the triangle. Okay, triangle PQR is a right triangle. And with hypotenuse PQ. PQ is the hypotenuse. So if you're filling that out in your book, PQ, segment PQ equals the hypotenuse. Did I spell that wrong? T-E-N-U, no, that was right. Hypotenuse, right? And PQR, triangle PQR is a right triangle, we already said. B, since PR is a horizontal segment, PR is a horizontal segment, its length A, length A is the difference between its x coordinates. That's true. So here's its x coordinates. Here's point P. This coordinate, it's got a certain x coordinate and a certain y coordinate. R has a certain x coordinate and a certain y coordinate. Notice how the y's are the same because you're at the same horizontal line, right? The x's, however, are different. This lies in a different spot than this. So this is considered x1, the first point. This is considered x2, the second point. So now it says to find the difference between the x coordinates. So how do we find the length here? Well, we could count, right? But we're not going to count. We want to do it algebraically. So we know that the distance, the y's are the same. Nothing's changed vertically. That's staying the same. However, these 2 points are going to change, right? So we know that the distance is going to be x2, that point, minus the first point. So that would be letter B. A is equal to, right here, A equals x2 minus x1. Right? Because we take the second coordinate minus the first coordinate to get the distance. So if this was 6 and this was 3, our distance would be 3. If this was 10 and this was 4, our distance would be 6. Okay, so far so good. Letter C, let's look at QR. If I can get this to show all at once. QR is this point and this point. I wanted to show them together, but so we see now that because it's a vertical line, the x coordinate staying the same. This is your x2 point. The Q point is also the same x2 point, right? The only difference now that's changing is the up and down. So the y is changing, the vertical. So this is point y1, and this is now point y2. So how do I find the distance up and down between these 2 points? Well, doesn't B equals the distance of y2, point up here, minus the distance of y1. So far, so good. Now, we are going to use the Pythagorean theorem to find the length of PQ, our hypotenuse, to find the length of D. So we know that D is really equal to, I'm just going to put in parentheses, it's really C, right? That's another way of labeling it. So now I'm going to do that up here. We know that the Pythagorean theorem is a squared plus b squared equals c squared. So we are going to put in, well, we're going to change this to d squared because we're changing, we called it d, right, distance, and that's okay, a squared plus b squared because we want that. So I just changed up the letter to d, doesn't matter, same thing, same length. Now to find d, isn't d equal to the square root of a squared plus b squared? Isn't that how you figure out your C, the Pythagorean theorem? Okay, so now we're going to replace a squared and b squared with what we figured out over here, the other formula that we can use for a squared and b, or a and b. So we know that a is really going to be x, okay, got it, x2 minus x1, and that's squared. That's our a squared. Remember, we got the square root sign all under there. Plus, what is our b squared? Well, let's go look over here. y2 minus y1, and it's squared. So we're going to square it. And all of that equals d, right? So we have just derived an important formula that you will be using a lot. It is called the distance formula. So I have that written bigger. I thought I wrote it bigger here for you. This is the distance formula. I put d on the other side. Distance is equal to the second coordinate point minus the first coordinate point squared plus the second y coordinate point minus the first y coordinate point squared, and then you take the square root of that, derived from the Pythagorean theorem. Okay, hopefully that makes sense to you. Now what I'd like to do is do problem on page 389. So I'm going to bring that up here under the back camera. 389. I drew a picture here. This is how you can use the Pythagorean theorem in real life. Remember I said engineers use this and architects and that. So yes, definitely will be useful. So I'll read the problem. It says, this is example 2, page 389. Francesca wants to find the distance between her house on one side of a lake and the beach on the other side. House is here, beach is over there. She marks off a third point over here, forming a right triangle as shown. The distances in the diagram are measured in meters. So you have here a coordinate point, you have here a coordinate point, and you have a coordinate point up here. And it says, use the Pythagorean theorem to find the straight line distance from Francesca's house to the beach. So how far is it if you go directly to the beach from her house? I know that wouldn't be easy to do unless you have a boat, but let's do this. So she couldn't figure it out because of the water in the way, but she was able to figure out a distance from her house over to this point and from this point to the beach. So doesn't she have a right triangle in this corner? So she just needs to figure out the distance of the hypotenuse, right? So to do that, we are going to do a squared plus b squared equals c squared. So we need to figure out the distance here and the distance here. We'll call this A, we'll call this B, and we already know this is C. So to figure that out, I have to count, right? But I can't just count because I didn't do this to scale, did I? So I can see that the y coordinates are both 20 because we haven't moved up or down, but the x coordinates are different. So the distance is really x2 minus x1. See that? Now you can. So 280 minus 10. 280 minus 10 is 270. That is our distance, so that's 270 squared. Plus, now we have to figure out our B distance, that's our vertical distance. So if we look, the 280s are the same now because the x point is staying the same because we're going vertically. Now we have this difference, 164 and 20. So that's going to be our, put it over here a little bit, our y2 minus our y1. So y2 is 164 minus our y1, 20. So 164 minus 20 is 144. And we're going to square that, right? Because it's a squared plus b squared equals c squared. And c squared, we're trying to figure out c, the direct distance from our house to the beach going across the lake. So now I need my calculator because I'm going to multiply 270 times 270. That's going to give me 72,900 plus 144 times 144. That's going to give me 20,736. You're welcome to hand multiply that as well. And that's going to equal c squared. So let's add that together. 72,900 plus 20,736 is equal to, I think I did that wrong, 72,900 plus 2,736, 93,636 is equal to c squared. How do we get to c? Do a different color. Square root both sides. That will leave us with c on this side. And what is the square root of 93,636? Well, I'm going to use my square root key on my calculator, and it gives me 306. If you had to estimate that, you'd have to go up pretty high. You could start with 300 times 300 and see where you're at and go from there. And then you'd be at 90,000. So you'd know you'd have to go up from there. So the distance from her house to the beach is 306, and I think it was in meters. Yes, so 306 meters. That's the answer to that problem. Now, I want to also show you how to use the distance formula to get the answer, because you're going to need to know both. So same thing. I'm going to pick a different color here, maybe pink. That's usually harder to see. Green, I have a dark green, I'll do light green. Okay. Now, let's use the distance formula. What is the distance formula? D equals, well, that's almost the same green, isn't it? Oh, well. Square root of x2 minus x1 squared plus y2 minus y1 squared. It's almost a little bit like the slope formula, kind of, in a way. A little different, but kind of got the x's and the y's similar. So now let's plug in our numbers that we know. You might find this easier than using the Pythagorean theorem. D is equal to the square root of x2. Which ones are x2? 280 minus x1, 10. And we're going to square that, plus our y2, let's go up here, 164 minus y1, 20, and we're going to square it. Do you see what we're doing? We're doing what we just did with the Pythagorean theorem exactly, aren't we? So 280 minus 10 is 270 squared, plus 164 minus 20 is 144 squared, and that D is equal to the square root of all of that. You see how it's exactly the Pythagorean theorem? So we already figured out 270 squared is up here, 72,900 plus 144 squared, we figured out up here to be 20,736. And I know I'm getting small here with my numbers. See if I can put this underneath to get a little bit more room. And then we add that up. So now D is equal to the square root of 93,636, because 72,900 plus 20,736 is 93,636. Okay. Then we take the square root of that, which we did up here, and we get D is equal to 306. So the distance is equal to 306 meters. So you're doing exactly the same thing with the distance formula as you are doing with the Pythagorean theorem. So you need to know both. Okay, I want to do guided practice page 390. So I'm going to go back on the screen. We're going to work those out together. Okay, here we are on guided practice page 390, and we are going to do some of the problems that similar to what we just worked through. So approximate the length of the hypotenuse of the right triangle to the nearest tenth using a calculator. My calculator here. Okay, so we have to figure out the length of each side. Which one's the hypotenuse? The side opposite the right angle. So here's your right angle. So this is C, the hypotenuse. And then A or B could be either one. We'll put this as A. And we'll put this as B. Now we have to figure out that distance. So the distance, we're going to, are these 1 to 1? Let's make sure. 1, 2, 3, 4. Yes, they are. So we just count. 1, 2, 1, 2, 3, 4, 5. So B is equal to 5 over here. And A is equal to 1, 2, 3 over here. Make sure I'm counting that correctly. 1, 2, 3. So we use the Pythagorean theorem. A squared, and my square doesn't look good. B squared equals C squared. So A squared is 3 squared. And that's going to look like 32, isn't it? I'm going to handwrite it. So A squared is going to be 3 squared plus B squared is going to be 5 squared equals C squared. So 3 squared, 3 times 3, 9, plus 5 squared, 5 times 5, 25, equals C squared. Add up 25 and 9. 25 plus 9 is 34. 34 is equal to C squared. And then we do what? What's the last step when you have a variable that's squared? You take the square root of both sides, square root of 34, and square root of C squared. And that's going to give you C on this side is equal to square root of 34. If you don't have a calculator, you can know that, well, 6 times 6 is 36. That's pretty close, isn't it? And 5 times 5 is 25. So it's going to be between 5 and 6. It's going to be closer to 6 because 34 is closer to 36. So it's going to be 5 point something, right? It's going to be over half. So I'm going to take my calculator now. 34 square root it. 5.8 is a good approximation. So 5.8. Remember how we did that in the beginning of the year? You didn't think you'd have to do it again, did you? But you do, right? So 5.8, and that's units. It's only in units. So the answer to number 1 is 5.8 units. Let's write that in there. 5.8 units. U-N-I-T-S. 5.8 units. And then I'm going to get rid of all the rest of this now. Okay. Next one, number 2. Find the distance between the points 3, 7, and 15, 12 on the coordinate plane. Okay, it might be a good idea to show that. So we have different numbers. If you notice, we have different x's. Let me pull my spotlight up. We have different x's and we have different y's, don't we? So let's plot these. We'll plot them over here with a different color so we don't have to make a new coordinate graph. So 3, 7, 1, 2, 3, and 4, 5, 6, 7. Somewhere up here is 3, 7, right? 3, and we're not being exact here. We don't need to be. And 15, 12, it's going to be way over here somewhere, and it's going to be way up. Let's move my picture. It's going to be way up here somewhere, right? That's going to be 15, 12. So they're not exactly horizontal, and they're not exactly vertical, right? So how do we find the distance from a different color? How do we find the distance from here to there? If it's at an angle like that? Well, we could use the Pythagorean theorem, right? That's one option. We would draw a line from here, and we would drop down a perpendicular from this point, and now we have the Pythagorean theorem that we could use, and we'd have to figure out what this point is right here. Oops. We have to figure out what this point in the corner is right here, right? That would be, it would have the same x point as this one, right? So it would be 3, right? But it would have the same y point as this one, right? The y point would be 12. I wish I had used red for that. Hard to see that. But now we have all the information we need to figure out. Now we can find the distance from here to there, right? We can find the distance from here to here, and then we can do a squared plus b squared equals c squared, right? So I think what we're going to do is both, because I want to show you the distance formula and the Pythagorean theorem again. I think it's a good idea to work through it. I'm going to cover up some of that space so we can have some white space. Now I made too much white space because I blocked my picture up here. Okay, there's my picture of my triangle. So we can know that a squared, and I'm going to use red again. A squared is the distance from this point to this point, if we're going to call this A, right? We're going to call that A. So 3's are the same. The vertical distance hasn't changed. The horizontal distance has changed. So that was 3, 7, wasn't it? Yeah. So we have x2 minus x1 for the first distance. So 12 minus 7 for the first distance. That's going to be our A distance. So 12 minus 7, 5, right? So it's 5. And our B distance is going to be this one. And that's going to have the same vertical distance, but different x points. 3, doesn't seem right. What did I do wrong? Oh, I see what I did wrong. Let me erase. This is going to be different. Okay? This is going to be 15. I'm going to use red because I wanted to use red before anyway. So this one is 15 because it's the same x point as the one up here, right? Glad I noticed that. And then I'm going to just put the other one in red too here. And that's 12. That's one. That one is correct. Okay. So our A distance then is really, that's the same. Nothing's changed with that. Or has it? Yes, it has. Let's clear this. Start this over. Now I lost my white space. Let's put that back. My white space is too big again. We can pretty much see it, I think. Down just a little bit. Okay, so we went, something should have stayed the same. The 12 should have stayed the same as well. So I'm going to go back again. Keep it at 12. I mean 7, not a 12. What am I doing? Sorry, guys. If I'm not confusing anymore. Okay. So let's go back for just a second and take a look at this. How did I get this point? Well, I know that the 7, it's staying on the same vertical plane, right? So it's going to be a 7. But the x-coordinate is going to get bigger. And it's going to be the same as this x-coordinate up here because these two are staying the same. But the 12 is different, right? So now my A squared, or my A, is equal to 15 minus 3. 15 minus 3. That's my A distance. My B distance is going to be 12 minus 7. So my B is 12 minus 7. Okay? So 15 minus 3, 12. B distance, 12 minus 7, 5. And now if I use the Pythagorean theorem, A squared plus B squared equals C squared. I'm going to just double check. Yeah, okay, so let's see what happens. 12 squared. This, by the way, this is a famous right triangle with the Pythagorean theorem. 12 squared plus 5 squared equals C squared. And these are really good to memorize, these kind of triangles with these side lengths. So we're going to figure out what that side length is in just a moment here. So 12 times 12 is 144. 5 times 5 is 25. Just so you know, my brain is like way ahead of my hand and being able to write this on the screen. So I'm like thinking way ahead, and then my hand says, no, you have to slow down because I'm on the computer screen. Okay, So 144 plus 25 is 54, 64, 65, 66, 67, 69, 169. And you may not notice that that is a perfect square. Anybody know what that perfect square is of 169? I know you're just all thinking, y'all like, yeah, I knew that right away, right? The square root of 169 is, I'm going to move myself over here again. The square root is actually 13, and that is a famous triangle. So C is equal to 13. So what was our goal in all this? To get the distance between this point and that point. So it is actually 13 units. So a 5, 12, 13 is a very famous Pythagorean theorem right triangle. And all the multiples of 5, 12, 13 are also very well known. So that was using the Pythagorean theorem. Now I want to use the distance formula. So it's going to be the same thing. But let me grab a blank spot over here now. So let's use the distance formula. What is the distance formula? Do you have it memorized yet? Because you're going to need to memorize it. Distance, oops, I gotta grab my writing tool. Distance is equal to the square root of, wrong one here. Sounds a lot like the slope thing, right? X2, it's going to take forever to write this, but minus X1 and square it, right? Plus point Y2, hopefully you all said it already out there, minus Y1, it's supposed to be a Y, and that is squared. And I don't want you to get confused and think that's an X. Let me fix that. Okay, square root of all of that. So we just plug in the numbers. So we have our two X points here. We have a 3 and a 15, which is what we did over here. We did 15 minus 3. We do 15 minus 3, and then we square all that, right? And then we add to that. That's a squared plus b squared, right? What's the distance for b? We got y2, 12, minus y1, 7, 12, minus 7, and we square that. And then we take the square root of it, just like we did over here. 15 minus 3 was 12 squared plus 12 minus 7 is 5 squared equals the square root of that. All of that equals d, or d equals that. There we go. I'll move myself up here now. So now we have, I just want to make sure that I'm recording because sometimes I forget. Okay. So 12 squared is 144. And 5 squared is 25, and you get where I'm going with this. The same exact thing as I did over on the right side. Take the square root of the addition of 144 plus 25. It becomes the square root of 169, which we said was a very famous number of 13. So the square root of 169 is 13. So we get 13 either way. It just depends on which way you like better. Do you like the distance formula, or do you like the Pythagorean theorem better? That's up to you. So we showed you both ways. So I'm going to clear this, all of these drawings, and let's look at number 3. And I will also put some more white space down here. Oh, it's too big again. Move it down a little bit. Right to there. A plane leaves an airport and flies due north. So we have our plane drawn right here. He leaves the airport and he drives straight north. That's due north. 2 minutes later, a second plane leaves the same airport, over here again, flying due east, straight east. Here's the other plane. The flight plan shows the coordinates of the two planes 10 minutes later. So these are the coordinates up here. The distance in the graph are measured in miles. Use the Pythagorean theorem to find the distance shown between the two planes. So we're not going to use the distance formula in this one, we're just going to use the Pythagorean theorem. I'm only going to show you one method, but if you like the distance formula, you're welcome to use that. So we have to find A and B. Which one is C? The distance we're looking for, right? How far apart they are. So this can be A if we want. This can be B, does not matter. So we have to find the distance now. How do we find the distance from the airport to the second plane here? Well, the y coordinates stay the same. The x coordinates change. So it's x2, 68, minus x1, 1, equals 67, right? So b is equal to 67 there. And just by the way, when you get into high school, next year you're going to be using the distance formula, but you're going to have, this might be negative numbers instead of all positive. So you're going to have to consider and keep that in your mind that sometimes you're going to be subtracting the opposite of a negative sometimes. Okay, the A point here is that the ones are the same. The 80 minus the 1. So y2 minus y1 is 80 minus 1, which is 79. So A is equal to 79. So now we plug that in. And we get A squared of 79. And we have to square it. Plus B squared of 67. And we have to square it. Equals C squared, right? So now you are welcome to multiply out 79 times 79 for the sake of time. 79 times 79 on my calculator is 6241. So 6241 plus 67 times 67. 67 times 67 is equal to 4489. 4489 equals C squared. Okay, and now we're going to add 6,241 plus 4,489, and you get 10,730. 10,730 equals B squared. What do I have to do next? Last step, different color here. Take the square root of both sides. This would be a hard one to estimate. Calculators would definitely be helpful here. So the square root of 10,730 is 103.6 about. 103.6 is equal to C. So what's the question asking us? Find the distance between the two planes. Distance is 103.6 miles. 103.6 miles. Okay, last question. Number 4, describe 2 ways to find the distance between 2 points on a coordinate plane. So the 2 ways are, I hope you know, what are the 2 ways we did? Oops, my capitals here. Why is it still capital? Pythagorean theorem. Try to spell Pythagorean, it's kind of hard. Actually, that's one way to find the distance. How else can you find the distance? The distance formula, right? So those are the 2 methods. Which way you like is up to you. Let's look at what our homework is. Here are my drawings. Our homework then, do I have the homework? Yeah, I think I do. I think I still have all of this still from the last video still on here. Read all that. You have that, by the way. I shared that to you. Okay, your homework then is to do guided practice page 390, which we just did. And independent practice, page 391, it's going to be very similar to what we have just done. And I think I can stop sharing. And yeah, so it's good to be back in the classroom here today. And I hope you have a good day, and I will see you soon. Bye.